Freefall can be seen as any motion of a body where gravity is the top force that is acting upon it. It is important to acknowledge that freefall has no outside force acting on it besides gravity. You can think of it in the way that the moon rotates around the earth. The moon is in a constant freefall, but because of forces of gravity, it stays in a continuous orbit. In a freefall, gravitation is reduced to a space-time curvature. The same is involved with a spacecraft in a continuous orbit around Earth. It uses calculation of Earth's gravitational pull aligned with the spacecraft being in a constant freefall to stay in a direct path or an orbit. Another example of freefall could be the observation of two objects being dropped from the exact same height. Due to the fact that the only force acting on the object undergoing freefall motion is gravity, there is no outside acceleration difference to the two objects, no matter the weight difference. And the objects at subject would then hit the floor at the exact same time. That's why in the video to the right, without deceleration due to air resistance, a feather would hit the ground the exact same time as a heavy ball. Because Earth gives everything the exact same acceleration, objects with different masses will still hit the ground at the exact same time if they are dropped from the same height.
One, release.
Now that we have an idea about what free fall in physics is, we are going to try an experiment. So this can be done at home or in the classroom. What you're going to need are two things. You can use a rock or a ball as well as a piece of paper. And what we're going to do here is we are going to find a place that's a little higher than maybe how tall we are, whether that be on top of a desk, a balcony. Sometimes the higher the better. It'll prove your experiment. And what we are going to do is we're going to crumple a piece of paper. And before you actually begin, you should probably think about what is going to happen. So we discussed before that two objects dropped from the same height will hit the ground regardless of their weight at the same time. So do you think this is the case for the paper and the rock or the paper and the ball that you're using? So before we begin, just write that experiment or write that hypothesis down really quick. And then we will look at our experiment. So now that you have that written down, as you can see in the experiment, both are falling at the same time and will most definitely land at the very same time. And so think about it this way, like, why do you think that is with the paper? Although they are different weights, what is it about these objects that even though they're different materials, does it occur that they fall at the same time? Now that we've thought about it a little bit more, next we can ask the question, why does this work? So if you'll notice here, x equals 1/2 times gravity times time squared. This is the equation for a free-falling object. So notice the consideration of there's no m for mass. So because gravity is equally acting on every object and the gravity is the only force causing an object to fall in the instance of a free fall, then all objects will fall at the same rate and time when dropped at the same height. So as you can see in the picture on the right, there was this old idea by previous scholars that the heavier weight was going to fall a lot faster than the lighter. But after Galileo discovered that this is actually not the case, and when he conducted the experiment, as you can see here from the tower, he dropped it, and both objects fell at the same time. So the keynote here is that in an equation like this, or in our scientific practice, there is no consideration for the mass or the weight of the object, since the only force really acting on our object, like our paper or a rock or ball, is gravity itself. So it's almost as if like they just throw mass out the window. It doesn't matter. So yeah.
So the main person who proved the theory of free fall was Galileo. And when we're talking about free fall, like in the previous slides, we kind of looked at objects that were just falling down, like the picture of the balls falling off the Leaning Tower of Pisa. When Galileo was experimenting, he thought it was a problem just dropping objects off of any kind of height, because he couldn't measure accurately the time that the objects would hit the ground. So in order to avoid this or fix the problem, he decided to put balls, different weighted balls, on a slope, and that was inclined. And then he could measure the time that those balls got to the bottom, because it was slower than just dropping them straight down. And what he found from this experiment was that the ball was actually moving because of gravity, and it had nothing to do with the weight. So no matter what the weight was, if the balls were on the same incline, they would hit the bottom at the same time. Some ways that we experience free fall in real life is from fruit falling off of trees. So basically, because of gravity, the fruit actually separates from the tree and falls to the ground. And then another example that we can see of free fall is when people go skydiving. They're actually experiencing free fall before they, pull their parachutes. But basically, you're experiencing the gravitational pull of Earth, which is exactly what is happening when we talk about an apple falling from a tree or different weighted objects falling